Okay, this is the first in a set of short videos showing how to convert the wooden panels, so we've got a whole load of them here, into Gurdies. You can see them building up here. So to begin with, let's get one out. You can see we have a base panel with 4 vertical bulkheads glued into it. So if we take a step back from that, just start with the panel. Right, now you'll see here there's a lip, and the side panels will glue into this so that when you tape it with car paint masking tape, it won't go in too far and it won't come out too far. It'll be exactly right. So if you look, that's made of 2 thin panels glued together. We turn it over. What I've done is, unfortunately I don't have any of the bare panels, but there's a panel underneath that has little holes drilled in it, and they are there to take the cover plates. This is the underside of the hurdy-gurdy, and you remember there's 3 panels that are removable. So what I've done is, this panel, I've just put it in with 2 tiny screws, there and there, and this one here, and then I use that to locate the upper one as I glue it down. So this panel and this panel are holding this top plate in exactly the right orientation. Otherwise you'll find when you glue it, it's not quite in the middle, or this edge here is smaller than this one. So it's quite important to get right. So screw that down, then take this top panel and glue it down on top. Use sparing amounts of glue. I use tight bond glue. It works really well. It comes in 3 kind of types. They're different colours. One's red, one's blue, one's green. Mainly, I think one of them is waterproof outdoors. One of them sets a bit quicker than the others. But to be honest, the original one is fine. I tend to just clamp everything and leave it overnight. Clamps, I mainly use these. You can buy them online in batches of 5 or 10. They're really cheap, to be honest. Just get a whole load. I mean, literally get 20, even if you're only making 1 Gurdy, because you're going to put all the clamps all the way around here. You'll easily use 10, maybe 15, and then just leave it set. So you've got that like that. So now I'll change my theatre prop, if you like. Go on to the next one. Right, now you can see what I've done here. I'm making this. So to glue this in at a 90-degree angle, I use a support with some blue tack on the top. This one's now set, so I can just take it off. Okay, it's decided to. Okay, I'll come back to that and get the blue tack off, but you can see what I'm doing here. I'm using these to make sure that these are at exactly 90-degree angle here. And the way I make these is I get a piece of a panel I bought from the DIY store, and I just cut the corner off. So I know this is then 90 degrees. So I didn't measure that and then cut that to 90 degrees because you'll never get it perfect. It's actually from a panel from a DIY store, just cut off. And I've got a few of these, and I just use the weight of it there to hold it with some blue tack on the top till it sets. So each panel, this one is 6mm thick, and you just literally glue it on like that. There's a notch cut in here. You can only glue it on one way up. You can't glue it on upside down. This one is a little bit more complicated. Hang on, I'll show you. It's made of 2 panels glued together, 2 3mm thick panels. This hole here, you see, lines up with this hole, and in there will go one of these. One of these. This is a commercially available cheap rechargeable phone bank, power bank, but there's no switches on the sides or the end or anything. It's really simple. Everything's this end, which means it slides in through here, and the end of it, you see, sits in there like that, and there's a 3D printed cover plate goes on there, holds it in. So that is why this panel isn't just a single piece of wood, that's why it's two pieces of wood. See there's tabs on the bottom. Those tabs, hang on, let's get another one. So those tabs go in there. Like that, with the hole, this hole facing that way. Right, now what about this panel? It's more complicated, isn't it? Well, that's, here's one I made before. This is made of two panels that are 6mm thick, and they've been glued together. Now, you'll notice there's a hole in each corner here. The only reason these holes are there is you can put a screw in there and there while the glue sets to hold it together. So those two screws are temporary. You take them out once the glue's set. Now you can see I've got a standard bearing here, and it's just screwed into pre-marked holes. Use shortish screws. That's about the maximum length of screw you can use. If it's longer, it will hit the drum as it goes round, the friction drum. So if these poke through the wood a bit, it's fine, but as long as it's not much more than that. Okay, and this hole is 8mm diameter. The rod of the crank handle rod will be held with these little tiny grub screws here. Okay, so you need to buy a set of screwdrivers with the hexagonal tips. You see that one's 1.5mm. So there's 1.5mm, 2mm, 2.5 and 3mm. Will cover you for the whole build, and you can buy them as a set for less than $10. Probably closer to $5. Right, now what is that? That's a guitar tuner. Standard guitar tuner. However, if you buy 6 guitar tuners, they're often sold in sixes, you'll get 3 right hand, 3 left hand. In other words, 3 of them, this tab will be this side, and on the other 3 it'll be on that side. So these are, I think these are sold as, I can't remember now, are they right-handed or left-handed? Anyway, you want them that design with the tab on that side, because you'll find there's a little screw there and there's a hole there drilled for you ready. So there's a piece that screws in here, and it all clamps up tight. I can't remember what size is that. I use a socket for that. No, sorry, next size up. Hang on. There, that's the socket for that. That is a, can I find where it's written on? So I can't even see the, oh, 10mm socket. This is used elsewhere. So that covers the build of the bottom half for now. Now what about the top half? This is the top panel. So if we turn it over, you can see I've glued a strip along here and a strip along here, and the reason they're there is, again, we need something for those side panels, these flexi side panels here, to glue against, to glue up to, so it's neat and tidy. Now there's no locating pins or anything for these, and there's no tabs like this to locate them. The reason being, could have done that, but it would make, you could have tab slots, for example, or something weird here, but it wouldn't be as nice to look at once the Gurdy's finished. So one part of this design is that on the top side there's no cut-out locating tabs for things like this, or at least very few of them. So that's a deliberate part of the design. Now you can see I've glued these on. Etched, here's part of it, etched into the underside there are lines, markings, locating lines, you can see here and here, and it runs all the way along here. So basically with your clamps you're going to glue this sparingly. You don't want the glue to squirt out as you clamp this down, because then the side panel won't go on neatly. So you put the glue on the here, you put it on the inner edge the inner half, not this, and you put it on really thin. You almost like wipe it off with your finger before you glue it together, and you see none of the glue is squirted out. So this is a clean recess here for the panel to go into. If the glue did squirt out, you could use some sharp pointed scissors like this or something and just quickly scrape it out when it's half set. And if it's still runny, get it out using a cotton bud. Buy a box of cotton buds before you make this. So if some glue squirts out here, you would run this in along here like that before it sets. Just use loads of cotton buds if you need to. Just buy a box of 100, 200 and get the glue out before it sets. And it's the same everywhere really. It just helps it go together neatly. So you glue them on. You can see we've got a gap at the end that's 6 mil. Gap at this end that's 6 mil. And you see how that then will locate against the end panels of the underside, because we're going to build this Gurdy. We're going to build the bottom half with the crank in it and the drum, top half with all the electronics, and then we're going to glue them 2 halves together. That's how it's going to work. So once you've done that, you've made that. And the other problem when you're doing this is when you put these clamps on, this will move slightly. So you really need to perhaps use a bit of masking tape in a couple of places before you put the clamps on, but you've got to be really careful it doesn't slide around on the glue when you clamp it up. Take your time, get it right, because it's like everything's in the preparation. So in these early stages, if you get this wrong, it's all going to look horrible as you continue. Right, so there's key box. There's a panel there. Okay, and there's a panel here, but you'll see there's nothing for it to fit into. So you've got to put the sides on. So here's one side of the key box. You can see how it locates. And it's hard with one hand, but you can see how that goes. Then the side, sorry about the motorbike. Side facing you obviously has got the markings on it and the labels etched into it. And the holes for the little buttons. So I can't do it with one hand, or maybe I can. Right, like that. Okay. And then finally this end panel goes on. So you can see how that goes on. Now it's important to note this hole, which has a USB socket in it, is at the top. This is gonna, oh there we are. Can you see that? It's at the top. You could put it in, you could glue this in the other way up by mistake. If you did that, if you attack it with a hairdryer on the hottest setting for about 5 minutes, the glue will eventually, you have to be patient, soften, and it will come apart. But you don't want to be doing that if you can help it. I've had to do it myself a few times because I made a mistake. But anyway, it goes on with the hole near the top. Really, we should have made these tabs unequal, so you could only put it in one way up. So again, you need to glue that together, making sure this isn't twisted in any way. It helps to put a small block of wood underneath this, inside of those end edges, so about that kind of size. Rest it on the block, apply, and then glue it all together. What about the circuit boards? Well, there's a reason I'm kind of obsessed by supplying these fully built and tested. It's because I'm sending them to another country and it doesn't work. It's a flipping nightmare. You end up with like emails back and forth trying to help people solve problems. It's easier. It's actually less work to just build it and make sure it works. Excuse me. So, how does it work? You can see here are the micro switches in 2 rows. You can see there's holes in the board to let the key stems go through. So I flip these over. You see each micro switch is soldered in at 3 points. This micro switch there. Then you've also got this row of buttons, and you've got some more buttons there. So they solder in the other way. Here's the solder on the back. There's a blue flashing LED that flashes with each buzz as you crank, and you can see that's slightly different, and that has to go in the correct way round, otherwise it won't work. Here's the computer. It's a Teensy 4.1 made by a company called PJRC in the States. There's a couple of resistors to do with the MIDI connection to the MIDI socket. Remember, we've got a MIDI socket on the top. This little chip here is like an optical chip. It's for MIDI in. We have another MIDI socket which is a MIDI in socket, so that if we ever did develop a pedal or something like that in the future, you would plug it into there, so it makes it future proof. So that's on there, even though at the moment you don't use it. Then we've got, this is only partially finished, you've got these trailing wires that come off. That goes to the crank sensor, which goes round. It looks like an electric motor attached to the end of the crank. You see it plugs in. This one will go to, I think it's one of the MIDI sockets. There's some wires to the big push button, which is like a gaming push button. See, I have them all up here in little racks. So here's the gaming video game type push button, and so on. So to be honest, it's better for me to assemble this and get it tested, even if you have to unsolder things and resolder them when you build it into your device. So actually the biggest time consumer is assembling this, programming this, testing everything works, actually, of all the steps. The other thing is the audio board. This connects to the audio board, which runs an audio signal then out to the headphone socket. So that's if you don't want to run it connected to a computer or anything like that, you'd use an audio board. Here are the audio boards. They're not particularly cheap. If you were to search Google something like music player MIDI audio board or something, you know, you can get things that'll play one track of music that will attach to a computer like that. Much cheaper than this one. The thing about this one is it's playing 6 tracks, because you've got 6 channels. If you think about it, you've got well, you've got 4 strings and you've got a buzz, so you've got 5 signals that need to be, some of them need to be turned on and off really fast. The buzz needs to be turned on and off with minimum latency. The same with the melody keys. So you need a music player that can play from a memory card. If you look there, there's a memory card that goes in there with all the recorded audio sounds on it. Every single possible note, every single drone note is on that. There's, you know, several hundred individual audio files. It has to select them and turn them on and off incredibly fast. Otherwise it wouldn't work as a musical instrument. It would work fine as a music player, but not as a musical instrument. And that's why it's expensive, because it's the only one out there that really is capable of doing it, to be honest, from anywhere in the world. So there you go. So that's the basis of it. And these circuit boards custom made. I have them made abroad in batches of about 20, and you've got a whole load sort of slowly evolving here. Now the other thing I've done is I get these are the crankshafts, the ends, they're laser cut from steel. Now the steel's quite thick. If you look at some Gurdys, they have quite delicate brass handles. Simply the reason I make them thick is, I mean, if you were to really force that, you could bend that by hand. It's just to resist damage during shipping. I mean, nobody wants their Gurdy to arrive with the handle kind of bent down. As I say, you could bend it back, but I just thought, well, it doesn't make any difference to the playability. I'll just make it a tad thicker. Now you can see the end, I've welded it on. It comes with a laser cut hole, 6mm this end for the bolt for the knob. This one's 8mm, same as this. It's a tight fit. I actually hammer these on just tap it on with a hammer, and then I use a TIG welder, which is that one over there, the blue thing. It's much neater than MIG, and you can see I get a really neat weld. it's not, again, traditionally they screw on. The handle can be unscrewed, but it can't work loose. You can still get this out if you really wanted to, because you would undo the hatches. There's 3 hatches on the underside of the Gurdy, loosen all the little grub screws on the bearings, and then it would eventually slide out. And that, again, that's how I assemble them. But I cheat because I assemble the bottom half completely before I glue the top half on with all the electronics in it. So you've got a mechanical half and then an electronic half. It's quite convenient that way. Now what I've done with this one, here's a pile of them, is I've put a spiral of, it's actually electrical tape on there, because I'm going to spray this end with primer and then black paint. I don't want any black paint on the shaft here, otherwise the bearing will not slide on. It's incredibly accurate fit. In fact, even the glue from this tape will foul it. So when I take the tape off, when I finish painting this, I clean this shaft here with 100% acetone. That's pure acetone, not the stuff you get from nail varnish remover, which is about 10% in water. Again, you can buy it online. You can get pure acetone in small bottles from chemists. It's used for removing those stick-on acrylic fingernails that some women like to have. It unglues them, but you have to ask for it. It's not always visible on the shelves, but honestly a bottle of this from Amazon will last you, for cleaning duties for just about ever more. As I say, these have to be perfectly clean for these bearings to slide over them. You see those bearings in the middle of the shot there? They'll just jam up, they won't slide otherwise. These are precision ground metal rods. I hesitate to say, but I don't know why Jack continues to use the threaded rods in the Digi-Gurdys, because threaded rod is not as accurate and it's often not even straight, whereas this stuff is precision ground. It is perfectly straight. That's the whole point of it, because then your wheel doesn't go around with like variations in it. Okay, so I'm going to spray up these now and come back to some gluing at a later date. I'm just going to run through now how you glue this on. Basically, I've got this piece of wood. These are offcuts. They're 3mm thick. They're held with blue tack, and then it's because I've got this lip here already glued on. It works quite well if I do it like that. Yeah. Then I put this screwdriver just under that end, and then I put the glue on sparingly on the panels, so I just have it on the edge with a tiny bit, not much, on each of those 3 tabs, and then the tabs go into the slot there and there, and then you can see how it goes. So in terms of clamps, I got some of these cheap clamps. Hang on, doing this with one hand. They go on like, whoops. So, right, can't do it with one hand. Put one on like that. Then I do this end, and the clamps for that end are, I put one like that. And then to make sure it gets pulled down, put one there, like that. Then I put a piece of wood on there, and then I put some books on here, or in this case I put my drill there. So the middle's pushed down. This bit, to stop a gap forming, I lift this end up, see, with the screwdriver, just a little touch, and then to stop that lifting up, I've got this clamped down, squeezing it down. So that's how you get the nice accurate join there. So I hope that makes sense. I'll take it all apart again. And there you have it. And then this is one of the handles, crank handles. So basically I put a spiral of tape around here. I hold it that way, and as I spin it in my hand, I've got an aerosol can here of metal primer, so I'm going psh, 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 as it's going round, and then I turn it over the other way and spray the top whilst also turning it around, and then I stick it in this piece of wood that has holes drilled in it like that, and let it dry, and then I take the tape off, and then I clean this with acetone. So there's the primer, and this is just satin black coat on top. Right, with these audio boards, there's a couple of things you've got to do to them. First of all, there's a tiny, it says, I don't know if you can see it, it says 5V there, and you can see there's a tiny blob of solder. Basically there's two pads. You've got to use your soldering iron, carefully get a blob of solder to jump the two pads. So you end up doing that and then lifting it off quickly, and it forms almost like a ball of solder. Obviously you don't want it to go everywhere else. Also then here, if you look at the orientation, 6 pins, only 3 of them are used. Solder them in, and then we can plug the ribbon cable from our board, or plug our main circuit board, or plug on there. Also a memory card will go in here that has all the audio files on it, one file for each of the possible notes to be played. So let's put that away. So now if I show you a completed circuit board, this is one of the reasons I don't really do kits. First of all, although this pushes in to female header pins, there's an extra wire goes there, right, and then to use all the possible pins, there's one of these boards. These are called something like memory card breakout boards. You see that emulates a small memory card there, and it's like a breakout board, so it breaks out the wires. So that goes in there. Then this plugs into the screen module, and this is a very tight fit, and if you're not careful it'll snap this thing off completely, and ruin your whole teensy board. It's very fiddly, so this is why I like to have these fully built and tested before I send them to anybody. So they've got all the wires added now, so you've got that goes to the screen. This one goes to the audio board. No, it doesn't. This one goes to the audio board. This one goes to the thing that looks like an electric motor, but it's actually an optical rotation sensor for the crank. These two go to the MIDI sockets on the top deck. That goes to the big black button, and then this goes to the potentiometer knob, the knob that adjusts the buzz position. So that's what everything does. It's a bit of a pain soldering all these on. They have to be the right length. They also have to be soldered on the right way around without making any mistakes. You see how these are twisted round. So again, that's why I like to test them before I send them out. And to be honest, most of the work is in assembling these, not so much the woodwork. I mean, there's a bit, but it takes probably more time to assemble one of these fully by hand. Right, so the next thing I've got to do is take one of these bearings, wind out the grub screws, slide it on the handle to about here, because it's going to be screwed in there eventually. And then the next thing is we slide it through there with this bearing on it here, and then as we get to about here we slide this onto it that way round. So this is commercially available flange with 4 bolts that go into these 2 aluminium discs, and it holds the discs together. And the discs I've been in a lathe and polished as it rotates, So you get a nice even matte kind of surface on it. So that's our friction wheel. So, and then so you slide that on there, and then you jiggle the whole lot through this bearing and keep going until the shaft is about there, and this bearing is up against here. So I'll do that now and then film it again. So there you are. So this is fixed on with some grub screws. You can use one of these spacers for the interior of the knob as a guide as to roughly how far in you should put the bearing. So you see this is on, and then we've slid it through there. And I must stress, if you've not cleaned that shaft with acetone, you won't get it through these bearings. They're a very accurate fit. It'll all jam and stick. I know you'd be trying to hammer them on, and it took me ages to realise all I had to do was get this squeaky clean. I was struggling away. Anyway, you learn. So I'm passing that lesson on to you. So there you are. You can see this is now held in with two of these screws, which are used for everything. This is locked into place. There's about 1 millimetre clearance between the tips of these screws and this wheel. Obviously you don't want it to rub. We may need some later adjustment to get it lined up perfectly, but basically you want it like it is there. You see it's about 2 mils away from this bulkhead. If you look at it like that, 2 to 3 mil, that's about the right place for the next part, which is the bit that goes underneath, which rubs on it. And then the encoder, you see, will fit on here later on. So while you're down here, you can actually put the guitar strap buttons on here. There's a hole for them. You can put the knob on if you want. You can put the battery. You could put the battery in if you wanted to, and also the guitar strap there to save time later on. Right, well, I've improved this. This is the interior of the knob. Now, what you don't want is this is a little bearing with some ball bearings in it. You don't want the sides of it to be gripped by anything, otherwise it stops it running freely. So this is actually a 3D printed spacer washer, which goes on first. Then you have the bearing. Then you have this spacer in the middle of the knob, which essentially has its own spacer washers printed into the end. See these little raised bits, but they're very thin. They compress against the inner part of the ball bearing race, allowing the outside to run freely. Another spacer washer, and then you have a nut. So, and then the whole lot goes through here. This is a nylock nut, which has a nylon insert, which means it doesn't rattle loose over time. Then when all that's on, this knob should just push on. It's a push fit over the bearings. So let's put this together now. So there you go. Obviously you just do this up finger tight. Obviously if you do it up really tight, it'll start crunching the plastic. But these bearings still run free, which is what you want. So that will then go through there. He said, there we are, like that. Nut on the back, and then this is a push fit. So there you go. Sometimes you have to adjust these nuts and things a little bit. I tend to hold the bolt still with a 3mm screwdriver, and then I use a spanner on that end without letting the bolt rotate. So just check these run reasonably freely. They still do. And then I'm going to just push this on. Now the way I push this on, sorry, it's hard to film with one hand. If it's at an angle like this, it won't go on properly, it'll all get stuck. So what I do is I use both hands. I put my fingers behind here, and I do the same with my other hand, and then I pull with my fingers, keeping it perfectly lined up as I go. And I try and do it all in one maneuver rather than stopping and starting. And yeah, it takes a bit of practice. So there you go. and you see it's reasonably free. And what you'll find is with a bit of if you just do that with your hand over it a few times, it'll actually loosen up even more pretty quickly. And you can see it's nice and neat. There's no big gap there. And the other thing, by convention, when you weld this on, or when I weld this on, this curve faces forwards. I think it's just convention. It doesn't really affect playing at all. It just seems to be how things are. So they want one rather nice, neat knob arrangement. Okay, the next step is to take your PCB with all the wires dangling off it, make sure they're all facing downwards, drop them all through the hole, all the wires through the hole, drop it in at an angle like that, and then you can see there's 6 holes here. And what you've got to do, and it is fiddly, you've got to put a bolt through 3mm, then a spacer on the inside, which is why I use these surgical forceps, PCB, then a nut, then I hold the nut with forceps and I turn the bolt head from this side with the 2mm hex spanner. See, this has got a hexagonal socket in the end, and I do the bottom ones first and then just do them up loosely, don't tighten them, then do the top, get it all nice, and then go along gripping the nuts without damaging the switches. It can be done, that's why these are curved, because you sort of come at an angle like that, and bolted into place. So you can see I've got the bottom ones in. Top one's relatively easy. Get it into position and then run along like this, and this, gripping the nuts and turning the bolts like that. Another thing I've done here is I've cut down some bolts, so there's literally about 1 turn of thread left on them, and then I've glued and I've tapped a thread into the holes that come in these laser cut inner panels. I've threaded the bolt in with glue on the thread, and you can see it's flush on the other side. And in fact, I'll go over that with a Dremel with a grinder disc just to make sure it is flush before the top panel is glued to this to form the lid. The reason I don't just glue bits of metal on here is they always come off in the end, because I'm using magnets to hold the lid on. I mean, if you look at this 3D printer here, you know, it's a pretty decent 3D printer. That's the magnet, that's the magnetic strip there, and the glue's gone all gooey and it's just come unstuck from where it's meant to go there. So at the minute it's a bit pathetic, but I'm just holding it with blue tack, so I'm sick of it basically. So this way these don't come out. I mean, you'd really have to pull hard to get them to come out, so that gives something for the magnet to attract and stick to. So this is the top panel now, fully assembled. So you can see you've got your 2 DIN sockets there, or MIDI sockets. Hang on, try and put it down on something. Got your gaming button. The potentiometer goes in there with the protective disc underneath for your fingers. That's so, well, it looks cool, but also it stops the grease from your thumb going onto the wood. If you want to turn the knob, if you look closely. You can use any knob you want. These are just a push fit, but I think these are quite cool because they've got numbers on. So if you adjust the setting and you want to go back to what it was previously, you can just remember what it was previously, basically. The PCB has been dropped down in, if you like, with all the wires hanging out of the bottom, and then it's bolted in with these spacers that are 3D printed. You need the spacers because the buttons on the back have a kind of body to them that's about 3mm thick, these buttons. And you've got to allow for the through hole solder wire sticking out a bit on the other side. So that's why we've got spacers. So if we turn it over, you can see, kind of makes sense how it all comes out through the bottom. So the potentiometer wire, it's got three wires in it, and it just goes on. There's no funny way of mounting it really, it's just in a row. The middle one goes to the middle pin. That's the only thing you've got to remember. This one, if you look at the wiring here, this is for the MIDI out. That's the main important one. You can see the red wire goes to, if you count these pins round, 1, 2, 3, 4, 5. Red wire will go to pin 2, the middle one will go to pin 3, and the other one go to pin 5 in a straight line. This is just the gaming button, so it just connects those two wires together. This is MIDI in, which isn't used for anything at the moment, but it's to future-proof it if we did want to fit a pedal or something. So basically this wire, the one on the left, goes to pin 2 if we're numbering that as 1, 2, 3, 4, 5, and then the other wire would go to pin 4, that one there. I think that's it. But this is for the headphone socket. It's just a through panel headphone socket. See, there's 3 connections there, middle one being ground. So the next step is we glue. We've got this, like I showed you before. We've got to undo that. Take this knob off, so you'll end up with a knob with a screw in it, in the top of it, and some like washers, a nylon one and a metal springy one. Take that off, and then we're going to glue this straight down on top like that. So here's one I did earlier. So you see that there. So you can still reach everything, and the main thing is you put the side panels on last. So you've got the maximum access to anything if you make a mistake. Now the other thing I need to show you before I forget is this mechanism here. So you've got, remember, you've got your bearing here, you've got your wheel. I've left about before I did these grub screws up, these are a 2mm hex key. I leave about a 1mm gap between the ends of these screws and the wheel, otherwise it'll scratch and rub on them. I do up these tiny grub screws here on the inner bearing. So I threaded all that through from this end. Remember, the handle's just welded on, so you can hold it like that as you're adjusting it through. You remember I cleaned the shaft with acetone. Now this is how this works. Basically, I don't know if you can see it, maybe not. There's a hole there, so you can see the pad. It's like a brake pad on a car, and the hole, you can sort of look through it and you can see some fluffy stuff. But the fluffy stuff is actually this. Hang on. It's thick felt, self-adhesive, and it's designed to go under the legs of furniture to stop them scratching your wooden floors. There's a piece of that glued on here, and it's in a curved shape to match the wheel, and then it's hinged here, and it's pulled up by this tuner with this thread, which is actually badminton racket string, and then this spring and a bolt. So the spring adds kind of constant tension, so if the wheel wasn't perfectly round as you turned it, you wouldn't notice a difference in friction. If you could use a stretchy thread here instead of a spring, that might work, but for me this works pretty reliably. And you might ask, so what happens if the pad wears out? Now, nobody's worn a pad out yet, but obviously it's possible. I don't know if you can see, but the end of this has got like a vertical bar on it, 3D printer, which fits into a slot here. This is glued on. If you loosen this off and you take the lower access panel out, then from underneath, it's a bit fiddly, you can lift this off out of the slot, because it pivots in the slot like a hinge, but there's no bolt through it or anything like that. It's just held in by its own, by the spring tension here. If you think of the forces involved, this just gets rammed down into this slot. You can lift it out, jiggle it around and drop the whole thing out through the bottom. So this whole piece, then you fully unwind the thread, it would drop out through the bottom. You could replace the felt, put it back together, reassemble it all through the bottom of the Gurdy if you had to. And the idea at least is you can look through that hole and you can see how much of the pad is worn and if you need to replace it. Obviously you probably end up hearing a plastic scratching against the aluminium disc, as you could tell by the change in sound, but that's the idea. And it's much easier to get it out through the bottom this way than trying to undo a bolt through this rib lower access panel and put the nut back on the end and all that kind of thing. So it's kind of simple and it works. So I've removed the tuner top knob part, put the glue on. You can see how I've got the glue on. There's no point in putting glue here because there's a hole there. Okay, so now we just plonk carefully, sort of get this roughly right on the top, and then start applying clamps from this end, working my way down. Right, so you can see how I've clamped this. It helps to jam it between your knees as you're clamping it. Now there's one more thing you need to do at this stage, which I'm going to eliminate from the design. We're going to modify the file slightly, but there's this laser cut piece which goes in there. You glue it in there like that, and it gives a tab here for some bolt holes for the encoder holder, which is this, which will bolt something like that into there. Obviously if you put the bolt holes just in the deck here, the ends of the screws would poke out through the top deck, so you want them to go through this edge here. So as I say, we're going to change the design, but for now you glue this in there like that. So I'll do that now. Right, so that's glued in, see there, and now we just put it down like these here and just wait for all the glue to set. Okay, so you've now got top and bottom half glued together. Next things are to fit. Got this panel here that we're going to fit the rotary encoder to, and we're going to fit it to the end of this shaft. And so we take one of the rotary encoders. Now I've modified these internally because they're meant to run on 5 volts, which is what USB voltage is, but actually that's really borderline. Really they need a bit more than that, but you can make an internal modification and then they work a lot better. So I've got a 3D printed mount. It'll bolt up like that. There's 3 bolt holes, screw holes. I soldered on a connector, and we need an adapter which goes from this shaft, which is 6mm, to the main crankshaft, which is 8mm. So we'll put one of those on and then I'll bolt them in and show you how that works. So these are the connectors. They're very slightly flexible, so if there's a slight misalignment it'll tolerate it to a point. So you've got these little clamp grub screws here. This side's 8mm, this side's 6mm. If you're buying these online, you've got to be really careful, because there is a version of this which is something weird size, like 6.18mm or something. It's almost 6mm. It's actually slightly bigger though. Whether it's some equivalent measurement in inches, sometimes they're shown on the site as 6mm, but they're not. they're slightly more. So read the small print, read the specs at the end of the listing before you buy one. But anyway, these are the right size. So that will go on there like that, and then the main shaft will go in there, and then we'll bolt this up. Okay, so you can see I'm just tightening up these little grub screws here, and then how this bracket will go on there, and then I'll drill 3 holes and put screws straight through, and those screws will go up inside the key box, so you won't see them from the outside. They're not going to come they're not going to come bursting through here. They're going to be just the inside of this panel. And again, I'm just using the standard screws I use for everything. Instead of having lots of different sizes, if you can, it's always best to just have one size for everything. So that's what I'm doing. So I use this drill with I don't know what that is, 2.5, 3 mil bit in it. Only the tip of the drill is in the chuck, because you need the length to drill down here without hitting this area here with the side of the rotating chuck. But basically, you put it all in place, hold it still with your fingers, drill 3 holes, put 3 screws in. Because screws have a I can't really call that, a taper there. If you screw them in too tight, it'll split apart the 3D print. So you just do them up till they just start to grip the 3D print, then stop. There's 3 of them. There's hardly any stress on this at all, so that's ample. So now you see, as you turn the handle, you are turning the rotary encoder. Okay, so the next thing to think about is putting the screen in. And so I've put the tuning knob back on. We've got 4 2.5mm diameter hex bolts. Got a whole load of them there. Through there. Here's the raw screen as it comes. You peel the protective film off, you take the foam off, exposing 7 pins. And it's just a sandwich. You've got the clear screen. This has protective film on, but I've laser cut these myself. You've got to scrape the corner very gradually with something sharp till the plastic starts to peel, and then carefully peel it off. And that will go from opaque to transparent. Yeah, and it's just sandwiched, you see. That on the outside, screen on the inside. Keep it simple, stupid process there. You can't do the nuts and bolts up too tight, you'll crack the screen. So you just do them up. I mean, I literally spin my screwdriver on the thin part, and when I meet any resistance at all, I stop and I grip the nut with these surgical clamps, which are ideal for this sort of fiddling around in small spaces. So of course, in use, that nut would work loose and fall off. So I put a tiny daub of glue on it. I tend to use this stuff. It's like a cross between a Evo stick type contact adhesive and the stuff used to glue plastic aircraft kits together with as a child. It has a sort of brown colour, and it's quite good as a multi-purpose glue. So that's there just to gum these up a bit, to stop them working loose. And then you plug in this lead, the one that runs, remember, to the adapter that's been shoved into the memory card holder on the little computer board. And the ground wire, which I've marked in black, goes to GND pin on this end here. Okay, the next thing is I'm going to take one of these. It's it's a headphone socket with 3 wires coming out of the other end of it, basically. So that's got to plug into the audio board and take the feed, the headphone socket, extend it if you like to the socket we've got on the top deck there. So you can see the black wire goes to the middle pin, the ground, and then you've got red and white. You bring it around cable tie through this hole, and you've got to make sure it doesn't bash into this friction mechanism. So sort of bring it around like that. So again, it's a bit of fiddly soldering. There's no way around it really. I did look at designs where we put the audio board into the Gurdy so it was right up against the edge, so you could plug the headphone socket into the socket on the board. This kind of works better, but of course it's another step in the manufacturing process, if you like, and it's a fiddly one as well. Okay, the next step is to put the wheel cover in. Now if you look at it, it looks symmetrical, but it's not. You should actually have, now if you look at that side, you'll see, sorry, I've got one hand here. You see the size of the notch there is a bit bigger than the one on this side, and that's the way it goes in. So you put it in, hook it in, you see how it's like a, pretty obvious how it works. So you hook it in like that, and then this one should go in as well. So I've hooked this side in first, and then make sure it's back all the way, and then that one should go. Just give it a wiggle to centralize it, and there you are. The next step is to take one of these rechargeable battery tubes. I've got a separate video on these, but basically you unscrew one end and put in a rechargeable battery. These are very basic mobile phone chargers. So you see the end of the battery goes into the hole there. Then this cover goes on, and you can see there's a slight lip on the inside which sort of centralizes the battery. There you go. And then you screw it in with two of these screws, and once the battery's in, you should never need to take this out, because you basically charge it through the small port and then draw power from the normal bigger USB port, if you like. Next step is to take one of these. You can see it's a panel mount old style USB socket on this end, a bit like you get in inkjet printers, and then the other end is this type. And so that needs to end up here, bolted through from behind, and then you loop the cable around, and the cable then actually goes, I don't know if we can see it from the top, into here. The other end goes into here. There you see. And then the bolts you need to do that are these. They sometimes come with these, and sometimes you have to buy them separately. They're 3mm diameter bolts. Now I've made a mistake here. This panel should be in with the hole down here, because you can see the back of this will foul the mechanism for this key. So I might as well show you. It often comes up on Digi-Gurdy forums how to rectify mistakes. So here's a cheap heat gun for like £20. You can use a hairdryer, but it'll take you about 5 minutes on the hot setting, the blowing air around here, to soften the glue. It's quicker with a heat gun. You can burn your fingers, you've got to be a bit careful. So apply the heat, put the heat gun down, and then push gently on it. So don't get too close to the wood, otherwise you'll actually scorch it, which is something you don't want to do. So let's try that. If I just give it a push, constant pressure, look, constant pressure, not too hard, starting to go. You might need a little bit more heat. constant pressure. Don't overdo it, otherwise it'll snap. And there you go. Right, that's it. That's all it needs. If you did it with a hairdryer, it would take longer. You'd need to apply the heat for about 5 minutes, but it would eventually go. So that's back in the correct position, clamped up, freshly glued. Wipe away the excess, no harm done. Just got to wait for that to set now. So while we're waiting for the glue to dry, this is the audio board. We're going to mount it with the headphone socket facing the wide side. There are two 3D printed brackets. The long thing I should have shown you before I glued them in. They're kind of long structures like that. There's one this end and one this end. So basically you put 2 lines of glue from a hot glue gun here, there and there, and then you kind of push them towards each other so the corners of the board get trapped in these structures. So there's black strip there, black strip there. Push them together, then squish them down into the glue, and then it holds the board, you see. If you needed to get the board out, you might be able to pop it out. You might have to snap a corner off here, one corner, or here, and get it out, which means you'd have to make a glued repair to get it back in. But basically I haven't glued the board itself to the wood. I've glued the plastic holders, if you like, to the wood. So it is still possible to get the board out without too much trouble. I mean, if I really wanted to get that out, I would have used something like a pair of these. I'd probably grab that and snap it back, which would break that bit of the 3D print. The only reason I would take the board out is if it malfunctioned completely. So there's the socket for the memory card, which has an audio file in the WAV format for every single note that could possibly be played on every single string, plus some buzz sounds, and each file has a number in front of it. So the computer, this one in here, connected to this board through these pins. If you're using the audio board, you've got the headphone socket with the headphones plugged into it. It'll select, the computer will tell it which sounds to play simultaneously. So this board can play multiple channels simultaneously, because obviously you've got, well, on our version, 2 melody strings, trumpet, drone, and a buzz. So it's got a code with 5 sounds, and of course the melody ones are being turned on and off very fast, as is the buzz sound. So there aren't many boards that can do that with low latency. That's a low delay time, and this is one of them. So in fact, it might be the only one. So that's why I use it. Right, that's how it should be, with the squared lower down, so we don't foul the stem of this key as it comes through. And then you can see these bolts. These are 3mm bolts, just going from the outside. And I usually put the socket in that way up. And the only reason I do that is that the leads I've got have a 90-degree bend in them, and when you plug it in that way round, it means the cable then runs away from you, so you can put your iPad on the table, for example, and plug it in, and it's all neat, and the wires aren't going the wrong way. So then next thing I've done is I've taking this cable down through here, round and up, see there, like that, and then plugged it in to the socket here on the computer board. I just want to make sure that the cable isn't rubbing against this, or where any of the keys might come through, like that. There's one there, you see. So it's well out of the way, so that's good. Next job is I took a Dremel with a cutting disc, sanding disc, just quickly went over that to bring it down flat so there's nothing projecting upwards. Then we glue this to the underside of this, and then I clamp it down to this piece of MDF with various clamps, so you end up with something like, where have I put it? So you end up with a lid like that, you see? And it's not twisted and it's not warped because it's been clamped down to the perfectly flat surface. Right, so finally you've got to connect everything up. So so the wire that came down from here with the headphone plug on the end goes into the headphone socket of the audio board. If you can see that, you've got green, white, black, red. So it's red to red on this connector, which runs up to this set of 4 pins here. There's 3 solder pins here. They go to the audio board. You can see that that has to go in that way round. The lead that's on its own at the end goes to ground. Sorry, I lie. I think it goes to 5 volt, the one that's labelled 5V. No, I'm wrong. It goes to ground. That pin's labelled ground on the board, audio board. You can see it there. Right, you can see it there. That one's marked ground, so it's ground, and then the middle 2 are used, and none of the rest. So if we show it you there. You get the idea. The other thing is, if you look, take this one that's not in there. There's a switch here. It goes forward when you're loading new firmware onto the board, and there's load. It goes back. It says run. Make sure that switch has been clicked back into the run position. And don't forget, it won't work unless you've got that little blob of solder there joining those 2 pads together. That means you can power this without using this socket. You power it from one of these pins from the Teensy board, this being the Teensy board. Any other connections? Yes, you've got 2 wires here to the big push button. You've got the 7 wires from that red adapter come in here to the screen. This one being ground, marked with black pen. You've made sure that this wire is not fouling the tensioning mechanism for the pulley. Anything else? Yeah. Don't know if you can see very easily, but you've got wires to the 5-pin sockets, which are like the old-fashioned original design of MIDI output. And the only reason they're there is, particularly this one, where you use, if you want to plug in a wireless MIDI transmitter, they come with that with a male 5-pin plug on the end, which fits into that socket. That's MIDI in. It's not used for anything at the moment, but if we did ever want to put MIDI information in, we could do it through that. And I'm thinking of something like a foot pedal or something in the future. So that's why it's there. So that's it really. So I've just tested it. It all works. And having established that it works, I can now fit the magnet holders, which are 3D printed here and here, to hold the lid on, and I can fit the sides, which I fit absolutely last thing of all. And I might use tape and hot gun glue just to hold some of these wires so they're not fouling each other. You've got to make sure nothing is rubbing on the shaft. It might wear through eventually. So you see none of the wires are rubbing on the shaft, so that's good. Yeah, so we're all good to go. Right, there's a bit of background noise here because my printer's going like the clappers, but and we've got the we've got the top panels with the metal bolts heads in, so we need to provide something magnetic for them to stick to. So what we do is we get these rod magnets, these little rod magnets, and they are glued into the ends of these parts. So on this end the panel slopes, so you can see how it will glue in. See how it goes down the side there like that. So this piece down the side is there to get it glued in at the right height. If it's too high, the lid won't fit properly. If it's too low, you won't get enough magnetic pull. So you see it's just right like that. Okay, so you push the magnet in, you glue the magnet into the hole flush with the top. It doesn't actually matter how far below it projects, so you could use ones of different lengths. They come in different sizes, different lengths. So I designed it like that, so if I used a longer one, it wouldn't really matter as long as you push it through so it's flush here and glue it. This is the glue I use. It's a slightly sort of rubbery glue. So on this end, which is flat, we have this one, this design. You see, and that goes in there. And you see again, you push it into the corner. Get my finger out of the way, hang on. You push it into the corner like that, and it ends up in the right place. And the reason there's a flat area here, and the same on this one, there's a flat area there, is so that while the glue's setting, it gives something for one of these little clamps to grip. So if we look at these over here, for example, you can see that, or that one there. So that's why they're like that. Try and make life as easy for you as possible. Now I have had someone where they plugged this in and out so many times it became loose. So if you need to change this lead, you see which bolts in there and runs through to here, plugs in there. What you would do is you would take a 2mm Allen key or hex screwdriver. Allen keys are those little L-shaped keys, and you would undo these two bolts. There's no nut on the back, the nut is embedded in the rubber of this, and then the other end you would unplug from there. It's not USB-C, in other words there is a way round. You need to just check. Now I use surgical instruments when I'm building these Gurdies, so I would do it using a pair of these, you see. I grasp it there, like that, and wiggle it up and down gently until it clicks in, not from making sure not to force anything. And of course you could say, oh yeah, but you've got keys here, and that's true, you do. So you have to remove the tangents from about 3 or 4 keys here, slide the keys out, and then you've got a window so you can see what you're doing down here. So that, combined with removing the lower 2 panels, gives you a bit of access, and obviously removing the lid and removing this key so you can see what's going on here, would allow you to change this lead, which runs, it's just looped down there and then it comes up and goes over here. You've got to be careful, you don't want it rubbing on the encoder all the time. You don't want it to hit the key stems either, which run through there like that. So you've just got to look, just think about how it's running, so it's not fouling anything. But that's how you would change that. The screen. I've had one person with a defective screen, so I might as well show you how the screen works. Right, there's a lead which runs from this red thing, which you remember is plugged into the end of the computer, and there's 7 wires in here. You see that one has been coloured black using a pen. That one, it goes to ground. You see the words, you might just see it there, GND, that stands for ground. So this plug can go in either way round, but only one way will work. So basically the wire with the black line on it has got to line up with ground. And there you are. Now you can see how it's held in. It's just 4 2.5mm diameter bolts with nuts on the end. Now I've put a daub of glue on the end of the nuts because you don't do them up tight, otherwise you'll crack the glass on the screen. So you do them up. I actually do them up by spinning the bolt with this, but I just hold this thin part, and as soon as I feel any resistance I stop, and I'm holding the nut with these. Now if you were to change the screen at the moment, it would be dead easy, because I would just reach in here, hold the nuts, and with the screwdriver I'd just undo the bolts. The screen cover is on that side, and then the screen bolts up from underside, then you just plug in the wire. But of course with the side on it's trickier, so you would remove this panel, remembering not just to yank it out, but remember you've got to unplug this plug here will come off this board, and also this socket, headphone socket extender, which runs to the socket on the top of the deck. That just plugs in there. You need to unplug that. So you'd undo the 4 bolts here, screws, move this out just about an inch, and you'd reach in and you'd start unplugging things. It's just that and that, but obviously do it carefully. Then this panel will come off, and then you'll have a better view of the screen, but you're going to have to reach in with either long-nosed slim pliers or tweezers, or a pair of these, or something like this, which you can buy on eBay. They're just called locking forceps, or surgical forceps, because you can see they lock. See the teeth there? They'll lock. So they're actually really useful tool to have anyway, usually for holding nuts in awkward places while you push your bolts through and spin the bolt. So it's something useful for your toolkit anyway. But that's how you would change the screen. And don't do them up tight, because you'll crack the glass on the screen. Just as soon as you meet resistance, stop, put a dab of glue on the end of the nut, once you've checked it's all working. Right, now the tricky thing, we're going to put this side on. I've run glue along each of these grooves, and then here. I've also carefully, with the cotton bud, put glue in here and there, because you don't want the end, when it's glued, to spring back out. Same there, very carefully. And then what I find is it's actually easier to start this end and actually start with that nub there, get that in, and then as regards these end pieces, I don't just bend them like that, I actually bend them up like that, if you like, and then feed them down like that into the end here, and then I use masking tape, which is like a not very sticky tape for painting cars and things, over the ends, and then I work my way along. Sometimes when you get to about here, it'll actually grip this very hard. It's hard to get it in, so what you do is you work it along, and then till you get that one in, and then you bend this end up into a loop, and then down and in like that, using tape as you go. So I've got this piece in here, and then this piece, I don't know if I can actually do it with one hand, but I sort of do that with it, you see, like that, and then go down, tape over there, wipe the glue off that squirts out, and then start working my way along this way, just forcing it in between the 2 panels. So there you go, I've got up as far as here now, and then again I'm going to loop this sort of like that and then work it down into there like that and tape it. Now you've got a choice here. These will want to stick out proud like that. You need them pushed in. So basically I'd push them in and I'd put a clamp on like that. I'd have about 20 clamps all the way along here. And that was very slow, but it works. So if you're just building one, it's not a problem. But that's why I came up with these contraptions, which I'll show you in a minute, which not only push the sides in, but then clamp them down as well. Okay, so this is the contraption I use to glue the sides on. You can see because of the shape of these, they squeeze the top to the bottom, but they also push in. So you see all these are pushing the sides in. You can also see the joints. If any glue squirts out, you can wipe it off with a cotton bud. And if it's projecting too much, you've got the opportunity to remedy that before the glue sets. So you can see everything, you can see the join. So I'll just check the other side. So you see that's all good along there. I'll just check the top as well. You can feel it actually with your finger now. So that's pretty good, so I'll just leave that now to set. This is one set of prints for the upper set of keys, and it's all the tangents for all the keys, or at least that's the plan. So to ease putting these in, they're actually numbered 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The ones with the wider stems have a recess in them, and that's so that you can put a tangent in like that that fits in the recess. And these are special tangents, they're slightly deeper and they fit like that with one screw instead of two, so it just speeds up assembly a tiny little bit. Just a small touch, just for those ones with the wider stems. So you're probably wondering why these tangents are such a funny shape. After all, they've only got to bash these micro switches. The reason is there's a tab. See the right hand side here, there's a tab that runs under the switch. So, hang on, I'm trying to do this with one hand. Right, these tabs are there so that when you hit the key hard, the tab will hit the circuit board before the switch is completely compressed. So if you hit the keys hard, that force isn't slammed into the micro switch mechanism, which will break it eventually. The switch will compress and it'll go click, but that extra bit of movement will be limited by this hitting the deck, so it protects the micro switches against excessive force. If you play very sort of gently, it wouldn't matter, but one or two people like to really smack the keys, and it just protects these switches, because these are rated for hundreds of thousands of presses before they fail, if not over 1 million. The next step is to use a 2mm hex drive and these 10mm long hex socket bolts, and you screw them directly into the wood of the key. Obviously don't over tighten them, otherwise you'll strip out the thread. If you do that, you can cheat and put a bit of glue on the thread. So you can see that now it clicks, and then doesn't matter how hard you push it, the underneath tab thing stops the micro switch being battered, and then the other end of the tab here acts as the return limiter. See, so this is flush with the deck here, and stops the key just dropping out. So that's why the tangents are that shape. And there are wide ones and narrow ones. You see on the wider stem keys have the wider tangents. these recesses in the sides are there because it helps me put them in, because I can grasp them like that, drop them in with these instruments. It's not so possible with the narrow ones, but that's why they're like that. Right, until recently, the way you did the top keys was you had a laser cut key that went in like that, and they were numbered 1, 2, 3, 4, 5, 6, 7, 8, 9, and then to make the key fatter there was a piece of wood shaped like this which you would glue onto the top, and obviously that was quite important to get exactly right. If it slipped slightly it would look weird. Now what I've done as part of an upgrade is, because I've got this printer which prints without a raft, you see it, this comes straight off the printer, unmodified, with a perfectly flat base, nice and smooth. Same with the sides. My older printer here, you had to would have to have actually sanded that on a piece of sandpaper to get anything like that, and it still wouldn't have been as good. So I've converted the top keys to these type. Now you can see the wider ones up to here have a slot in them, and they take what's called the single hole tangent. See, that tangent only has a single bolt hole in it, and it will actually, I'll show you on this one if I can, it will go in there, and you want it to go down into the recess. Hang on. Right there, it's almost a friction fit. So you see there, that's how it works. So there's different types, there's 3 types of tangent. There's the tangent with a single hole, they're for these upper keys which have the recessed slot in, and you put one of these bolts straight through into the plastic and it will hold it. Then the wooden keys with the wider stems take this type of tangent, which has 2 holes in it. As you can see, it's wider. Try and squeeze one in there by hand, and there's one there. And then when you get up to the top, you're going to need a narrower tangent. So you have this type, which has 2 holes, and it's the same, but it's narrower. And sometimes to get them in, you have to half take the key out, place it on top, and then put the key in. And then with bazillions of little bolts, they all screw into place. So the final step after you've done all the tangents is, I use a handheld belt sander, but basically you don't have to do it at all, but I sand these tabs off so they blend in with this here. See, like that? There, and the same here. As I say, you don't have to do it, but it just looks, I don't know, I think it looks, you don't have to do it, but I just think it looks a little bit nicer. So there you go, that's it.